are the last class of the day. Y'all are the class that's probably going to get recorded more often. So just realize that. So when y'all make comments and stuff, just know you're being recorded. So if you say something mean about me, I have proof. So y'all better not be talking mean about me. I'll turn the recording into the office. I mainly did it because of Aubrey. She says mean things sometimes. I want to be able to prove it. I actually want to keep up with how many times I have to tell Brady to pay attention. You know? What? Perfect timing, Brady. What? He wasn't paying attention. I said I'm recording your class mainly to figure out how many times I have to tell you to pay attention. I'm about to tell one of our assistant principals, hey, watch this video from today. See how many times I had to tell a kid in the class to pay attention. I don't disrupt the class. No, I'm not mad at you. But, you know, focus. Okay, so today, again, we're talking about something that I think you guys are going to find to be very simple. We're talking about exponential functions, okay? Now, first thing I need you guys to make sure you understand is this. Haven't we talked about functions that have exponents? Tell me one. Tell me a function that we've done quite extensively that has an exponent. Quadratics, right? Is a quadratic an exponential function? No. It has exponents, but it's not an exponential function. Okay? It's x squared, right? That's an exponent, but it's not an exponential function. What makes something an exponential function? You think you know? What actually makes something an exponential function? One thing. A quadratic has an exponent, not exponential. Okay? A cubic function has an exponent, but it's not an exponential function. What is the key that makes something an exponential function? What about the exponent? Not necessarily. No. What makes something an exponential function is that your variable is where? Yeah. When your variable is in the exponent spot, that's what makes it exponential. Okay? It's not like, well, if it has an exponent, it's exponential. No, quadratics aren't. Cubics aren't. If the variable is in the exponent spot, that's what makes it exponential. You got me? So, for example, the parent function of an exponential function is b to the x power. See, the exponent is a variable. Now, there's one rule of thumb, and that is b cannot equal 1. And this should make sense, because what's 1 to the 8th power? 1. What's 1 to the 873rd power? Still 1. So even if we had 1 to any x variable, it's not going to cause it to actually be exponential. So that means that your value could be one of two things. It could either be greater than 1, or it could be less than 1. If it's greater than 1, it's going to have what we call exponential growth. Yeah, it's going to have exponential growth. And because of that, it's always going to be increasing. So what are some things that you hope have exponential growth over time? Yeah, your money, right? Your salary, investments, or what you make. You want it to have exponential growth. You don't want it to go down. You want it to go up. What are some things that you don't want to have exponential growth? Your age. Yeah, well, age is linear. Age is linear. Because you're always changing at the same rate. Huh? Crime? What? Yeah, prices. Anything that you're having to pay for, you do not want it to have exponential growth. Unfortunately, it does sometimes. Yeah, you don't want death rates to go up exponentially. You know, you want that to be linear. I mean, now, if it's a value that's less than 1, we call it, does anybody want to take a shot at it? You probably learned it in science classes. Exponential, not decrease, but yeah, I heard it. Decay. Exponential decay. And Brady, what's it doing? You said it right. Yeah, it's decreasing. It's going down. So these are the two types. Exponential growth is when the base of your exponent is greater than 1. Exponential decay is when the base of your exponent is less than 1. Okay? Now, with exponential graphs, whether it's growth or decay, there's this weird thing that they all have, and it's called the asymptote. An asymptote. All right? This is some of the weird readings that you probably have done, Kamani. You probably know what an asymptote is, right? Yeah. An asymptote is a line that a graph will always approach, but guess what it never does? It never touches it. It never gets there. It's always approaching it, but it never gets there. So it's a line that a graph approaches, but never touches or crosses, either way. It can't cross it if it never touches it, can it? Now, I hope this makes sense. Y'all just talked about two different things that you would hope to have exponential growth or decay, and they all have to do with kind of money, right? Like, for example, we talked about your salary. You would always want it to have exponential growth. Here's the point. When you talk about your salary, can you ever make below $0? Are you ever going to have a job where you have to pay to do that job? You pay someone to come and do the job? No, there is a ceiling that you cannot go below it. You know? That's an asymptote. All right? Same with prices of stuff. The prices might go up forever, but are you ever going to pay negative money for something? No, there's a ceiling that it cannot go below. That's the idea of an asymptote. Now, specifically, when it comes to exponential functions, y'all need to know that exponential functions have a horizontal asymptote. A horizontal asymptote. Okay? Now we're going to talk about this. Y'all are going to actually give me the answer in just a second. But if a exponential function has no transformation whatsoever, then your horizontal asymptote is the x-axis. If it has no transformations whatsoever, your horizontal asymptote is the x-axis. Do y'all remember how to name the x-axis? Horizontal lines are all based on what axis that it crosses. Y. So how would you name the x-axis? Y equals 0. Y equals 0 is your horizontal asymptote for any exponential function that has had no transformations. Now let's go to that, and we'll talk about this later. Here's my horizontal line. Guys, what changes that ceiling to either go up or go down? What have we talked about a lot that will cause that horizontal line to either go up or down? Not a variable. Well, I guess it is a variable. What kind of transformation will cause the ceiling to either rise or lower? It's a translation. Which kind? What kind of shift? A vertical shift. A vertical shift changes the horizontal asymptote. A vertical shift changes the horizontal asymptote. Okay? Can y'all remember that? Okay, we'll get back to that in just a second. But quickly, let's go graph this real quick and talk through it We're going to go fast, really fast. So I'm going to reset my calculator. Second plus 7, 1, 2. Go to y equals, and we're going to do 2 raised to the x power. Graph. Y'all see how it's increasing? It's growing. See, the base of x is what? The base of x is what? The base of x was what? It was 2. That's greater than 1. It has growth, right? Okay, let's graph it. Second table. I'm going to find a couple of points. You don't need that many. I'm going to do 0, 1. That's an important one. What's that called? 0, 1. What's that called? Your y-intercept. I'm going to do 1, 2. I'm going to do 2, 4. I'm going to do 3, 8. Again, that's plenty. So let's go back and let's graph it. And here's how I'm graphing it. This is the mindset I'm graphing it with. I've got a 1 go through my points, right? But what can I not do? I can't cross my asymptote. So I'm going to draw this thing where it will not cross or touch my asymptote, but it has to also go through my points. Y'all got it? That's easy, right? Now, let's talk about things that we've talked about a bunch before. Domain. Will this thing ever stop going left? So what is it going to go towards to the left? All right. Will it ever stop going to the right? So what's it going to go towards to the right? Okay, that's easy. That's my x. It can go left and right forever. Unlimited. But what about my range? Yeah, it can't go below the what? It cannot go below the asymptote. So 0 to what? Positive infinity. Because look, it can go above that forever. So 0 to infinity. In behavior has always been something that you're going to keep seeing, and that is really simple. Look, as x goes to the right, guys, what's y doing? How do I describe going up? Positive infinity. As x goes to the left, what's y approaching? 0, right? The asymptote. So that's easy. We already found the y-intercept. What was it? 0, 1. And then the asymptote we said was y equals 0. Okay? Very, very simple. Let's do the next one. What's the base of x? What's the base of x? 3/4 is definitely what? Therefore, it has to be exponential decay. So here I go. 3/4 raised to the x power. This one's a little harder to graph because if you go to your table, the points are not as good. What is good, though, that we have? We got 0, 1. That's our what? That's our y-intercept. Let me do a couple of other ones real quick. I got 1 and 0.75. Let's see here. -5 is, let me see what that is. That's 1024 divided by 243. That's 4.2. So I'm going to go left 5 and then up 1, 2, 3, 4.2. And then let me get one more. Let me go up to negative. No, that's too high. That's 17 point something. That's 13 point. Let me try -8. That's 65536 divided by 6561. So that gave me 9.98. So I went left 8 and I went up to almost the very top. Okay, so here's what I got. Now, what do we know? I got to go through my points, but I cannot go below my asymptote. This thing did not have any shift, so we know that that asymptote is the x-axis. Whoops, bad drawing. So I'm going to draw it just like that. Whoa, too far. Perfect. So once again, easy. Domain. Left and right forever. Now, a lot of people struggle with the range because they think this is decay. But what can this not go below? But what does it do upward? Okay, even though it's decay, it's still from 0 and up. Okay, because we're looking at what y can equal. How about the range or the end behavior? As x goes to the right, what's y doing? It's going towards 0. As it goes to the left, what's y doing? Infinity. Then we said the y-intercept was 0, 1. That's easy. And the asymptote is y equals 0. Okay, easy stuff. Let's go to the back, and we're going to quickly talk about transformations. And this is simple to you guys, I promise, because you've done it all before. So here's the first thing I need you guys to identify whenever you see one of these. Find the variable exponent and its base. Anything that is not that has to be a what? Starts with a T. A transformation. So for example, sometimes you'll have an A out there being multiplied by it. And that A out there is two different types of transformations. One, if it's negative, what have we said that negative value out in front will cause to happen? A reflection. So if A is negative, it'll be reflected across the x-axis, like it has with every type of function we've done this year. Also, if that A value is either greater than 1 or less than 1, it causes a what? What do we call this? A vertical stretch or compression. So if it's greater than 1, it's a vertical stretch. If it's less than 1, it's a vertical compression. So that's what A out in front can tell me. But also, we've got what? We got up there in the exponent spot, we got that minus h, right? That could be plus h. Minus h plus h. We call that inside because it's in the exponent spot. And everything inside, we have said, is horizontal. That's your horizontal shift. Y'all remember the rule about horizontal? It's the opposite. So if it looks like a plus, it's actually going to go which horizontal way? Left. But if it looks like a minus, it's going to go what horizontal way? Y'all remember that? And you got one more location where we're going to have a transformation, and that's out to the right. That's your plus k, which we have called our vertical shift. And what do we say about vertical, guys? It is what it is. So what kind of vertical shift is positive? Up. And what kind of vertical shift is negative? Down. Now I want you to write one note on here, and I want you to think for a second, what is the note I need to make about that vertical shift?
It can't.
Yes, that's right, Addie. She said it. Asymptote. The vertical shift changes the asymptote. The vertical shift changes the asymptote. You got me? It's very good. Okay, so here we go. Ready? I'm going to write on all of these. On the top right, we're going to answer 3 questions. The instructions only say to answer 2 questions. We're going to answer 3 questions. I'm going to write asymptote on every one of these. I don't know. It's a pretty cool word, though, right?
Well, so always 0.
It is unless it does what? Unless it vertically shifts. It's always y equals 0 unless it vertically shifts. Okay? So, in fact, let's just knock that out on all these. Look at one. Does it vertically shift?
Yeah.
How? So it's going to move to y equals positive 5. Guys, this is number 2. Vertically shift. Nope, nothing's being added or subtracted on the outside. So what's its asymptote? It stays 0. How about number 3? Y equals 7. How about number 4? Y equals negative 2. See how easy that is? The vertical shift controls the asymptote. All right, now, if you didn't get that written, we're going to do each of these. We're going to go real fast. What time we got here? Oh, shoot. Things are tight. We got like 8 minutes. Oh, we're good. We're good. First, what I want you guys to do is identify the exponent and its base. That is the parent function. So what's the parent function on this problem? 3 to the x power. Anything that is not 3 to the x power is a what? Or, not translation, that's shifts only. Transformation, right? Anything that's not the base with its exponent is a transformation. So, how many does this one have? That's not 3 to the x. It just has that 1, doesn't it? And what is it? It's plus 5. What is that, though? Where's it at? Outside, so it's vertical. Vertical is what it is. So what's a positive 5 vertical shift? It shifts up 5, which is exactly why it changed our what? It changed our asymptote. So that's all you need for number 1. Look at number 2, guys. Find your exponent and its base. What is that? And that is our parent function. Anything that is not 1/4 to the x power represents a what? A transformation. So what do we got? We got that 2 out front. What's that going to cause? Vertical stretch. Y'all all seeing that? What else do we have besides the 1/4 to the x power? We got that x minus 1 in the exponent spot, which we remember is our horizontal shift. And what's the rule on horizontal shift? It's the opposite. So that minus 1 is actually going to be a positive horizontal shift. What's a positive horizontal shift? Shifts right 1. Y'all got that? Pretty easy, right? Look at the next problem. Find your exponent and its base. What is the parent function for this problem? 4/3 to the x power. I haven't been asking this question. Is that growth or decay? That's growth, right? 4/3. Don't let the fraction trick you. Still greater than 1. Okay? Anything that's not 4/3 to the x power represents a what? Transformation. So what's that first thing we see? That negative out front is going to reflect over the x-axis. Where's that plus 2 at? It's with the exponent, so it's inside. So that's horizontal shift. It's the opposite, so it's going to go what? Left 2. So it shifts left 2. And then where's that plus 7 out at? It's outside, so it's vertical shift. It is what it is, so it shifts up 7, which is exactly what changed my what? Asymptote. And last one, guys, find your exponent and its base. So my parent function is 5 to the x. Anything that's not 5 to the x, this is the last time I'm going to ask, anything that's not 5 to the x is a what? Transformation. So we got the 1/2 out there. What's that telling me? Vertical compression or shrink. That's fine. I've called it that before.
Why is it vertical compression?
Because that value 1/2 is smaller than 1. So it's going to take this exponential, this is an exponential growth, but it's going to flatten it out. Okay? It's going to compress it because that 1/2 is smaller than 1. What else we got? We got a horizontal shift. Which way? Shifts right 4. Because that's minus 4. It's the opposite. And it's going to shift how? Down 2. And that's exactly why our asymptote moved down to y equals -2. And that's it, guys. That's how you deal with exponential functions. And that's how you deal with your transformations. What do you think? So this worksheet, that's your homework. It's two-sided, but all I need you to do is the front, 1 through 7. You don't have to do the back. Unless you just want extra practice. If you want extra practice, there's the back side that has 4 additional graphs. But all I need for homework is 1 through 7. Okay? And that's it. Y'all feel good?